Given question, cylinder A weighing 4000 Newton and cylinder B weighing 2000 Newton rest on smooth inclines. They are connected by a bar of negligible weight. Find the force P to be applied as shown in diagram such that it will hold the system in the given position.
Let us understand given system. There are two cylinders A and B connected with the help of rod AB, and we have to find out the force P applied at the center B to hold the system in the equilibrium position. Now if we observe, the cylinder A is placed on inclined surface at 60 degree to the horizontal, and the cylinder B is placed at inclined surface at 45 degree to the horizontal. Now the inclination of this bar AB is also given 15 degree, and the force P is applied which is making an angle of 60 degree with the vertical. Weight of the cylinder A and B is also mentioned in the question. So first step is to draw the free body diagram. So first we will draw this cylinder A and cylinder B, and we have to connect these centers. Now this center, that is the line joining AB, is making an angle of 15 degree with the horizontal. So we have to mention this. So here is 15 degree angle. Now if we observe horizontal line passing through A and horizontal line passing through B, both are parallel, and this is the common inclined line AB. So this angle of this inclined line making this with horizontal line is also equal to 15 degrees. So these are the opposite angles. Now this cylinder A is in contact with inclined surface. So reaction developed. So we will say that here is the point of contact 1 and this is the point of contact 2. So reaction developed will be perpendicular to the inclined surface. So we have to show here this reaction R1. Now if I extend this R1, then it will meet to the center point A. Now how to find out its angle? So if we observe this R1, that is the line R1 passing through center, is perpendicular to this inclined line, and this horizontal line, if we observe, this vertical line also is perpendicular to the horizontal line. So angle making in between these two perpendicular line will be same, that is this 60 degree. Now we have to show weight. So weight always acts in vertically downward direction. So we will show here weight, that is equal to 4000 Newton. There is the bar AB which is connected to the center of cylinder A. So either there is the tension or there is the compression in bar AB. So we will consider here the compression is created, and due to compression the direction of this reaction force we have to show towards the center of the cylinder A. So we have to take the assumption, so we can take either direction, that is towards the center or away from the center. So we will consider here the direction of reaction is towards the center of the cylinder, and we will consider here the letter C. Now we will move to the cylinder B. Now if we observe here, there is the compression. So if this compression is towards the cylinder, that is towards the center A, then in the same way for the cylinder B there is the compression applied towards the center B. So it is equal in magnitude but opposite in direction. So we have to show this C. Now we have to find out this P applied, and which is making 60 degree angle. So we have to show as it is, and it is acting towards the center. So we have to show which is making 60 degree angle. So here is the P, and at the same time we will join this force P with the center and we will show the angle. So here the angle is 60 degree, and which is mentioned in the question. So this angle is 60 degree. Now there is the point of contact 2, and at this point of contact we have to show the reaction, and which is perpendicular direction to the inclined surface. So we have to show this, and which is known as R2. Now this R2 is making angle of 45 degrees. So if we observe, this R2 is perpendicular to the inclined surface, which is making angle of 45 degree with the horizontal. So if for this horizontal also, here is the vertical line is perpendicular. Now I will extend this R2. Now R2 is perpendicular to the inclined surface and this vertical line is perpendicular to the horizontal surface. So same angle at the point of contact in between these two lines, that is equal to 45 degrees. So we have to mention this. Weight of cylinder B is given 2000 Newton and it will act in vertically downward direction passing through center. So we have to mention here. We have to find out the value of P. So this is the question. Now we have to first find out the value of C, because C is connected to the cylinder B and it is also connected to the cylinder A. Now if we concentrate on the cylinder A, then there are three forces which are concurrent because they are passing through the center point A. So we can apply here the Lami's theorem. We will rearrange these forces in such a way that they are moving in the outward direction from the center A. So how to show that? So I will extend this C in the opposite direction. So here is the horizontal line and here this C. So direction will be same. Now it is making 15 degree angle with the horizontal. So here is also horizontal line. So same angle 15 degree, that we have to mention. Now we will extend this R1, that will passing through C in the outward direction from the A. So with the vertical line it is making angle of 60 degree. So if we observe, so here is also vertical line. So we have to show here 60 degree angle and it is R1. So we have to mention here R1C, and this 4000 Newton which will act in the downward direction. Here we have to show 4000 Newton and here is the center A. Now we can apply here the Lami's theorem. So our aim is to find out C. So how we can write this? So C divided by sine of angle between other two forces, that is in between R1 and 4000. So how to find out? That is 180 minus 60. Sine of 180 minus 60, which is equal to, now this 4000 is known, so 4000 divided by sine of angle between other two forces. So other two forces, how to find out? So we can say that 180 minus, now here 60 plus 30 is equal to 90, because this vertical line and horizontal line are perpendicular to each other. So I will mention this. Here the remaining angle is 30 degrees. So how we can find out the angle? 180 minus 30 minus 50. So sine of, I will write here 180 minus 30 minus 50. So this right hand side term is known and we can find out the value of C. Calculated value of C is 4899 Newton. Now we will move to the cylinder B. Related to cylinder B, this force C is known, P that we have to find out, R2 is unknown. But this R2 is perpendicular to the inclined plane. So we will resolve the remaining forces into two components. One component is parallel to the inclined plane and other component is perpendicular to the inclined plane. So there is no need to find out the value of R2. So we will first draw one line which is parallel to the inclined plane. Now if I make here one construction, from this point I will draw one horizontal line. Then this inclined plane is making an angle of 40 degree, because in between this horizontal and vertical line there is total angle 90 degree. So here the remaining angle is 45 degree. So from this vertical line I will mark one point which is at 45 degree. Sorry, not 40, it is at 45 degree, and I will draw one line. So this is the construction. So this line is parallel to the inclined plane and the line passing through R2 is perpendicular to the inclined plane. So these two lines, I will extend these two lines just for the understanding purpose. So this one line is parallel to inclined plane and this line is perpendicular to the inclined plane. Now we will resolve the forces. So we will resolve this component C. So one component is parallel to the inclined plane. So I will take this line parallel to this and I will resolve here. And other we will resolve which is the parallel to this perpendicular line. Now we will find out the angle in between this force C as well as this component which is parallel to this inclined surface. So how to find out? So for that we have to first find out the angle in between these two. So if we observe here, this angle made by this inclined line with this vertical is 45 degree. So here also with this vertical line, this angle is 45 degree. So what is the remaining angle? So remaining angle is, so here is the horizontal line and this is the vertical line. So remaining angle is 45. So total angle is 45 plus 50. So in between this inclined line, that is this line passing through C, and this line is 45 plus 15. So here also total angle is 45 plus 15. So I will write here as a 45 plus 15. So how we can write its a value, that is this component, how we can define, that is C cos of 45 plus 15. C cos of 45 plus 15. So we have to write this, and here the value is C sin of 45 plus 15. Now we have to consider forces parallel to inclined plane. So we will consider only this component. Now we will move next, that is for P. So for P also we have to resolve into two components. One should be parallel to this inclined plane. So I will show here, and one should be perpendicular. So here is, we have to draw the line parallel passing through R2. Now how we can define this angle? So angle in between this parallel line and through P. So if we observe here is, these two lines are parallel lines. So here in between this remaining, so total angle in between this vertical and P is 60. And the angle in between this parallel to inclined surface and the vertical is 45. So remaining angle is 60 minus 45. That is equal to 15 degrees. So I will write here as a 15 degrees. So how we can define this component? P cos of 15. P cos of 15. Now in the same way we will resolve this 2000. So when we resolve, we have to take one line parallel to this inclined surface. So here, and one is perpendicular, so we have to show this. Now we have to consider only forces parallel to inclined plane, that is this component. So how we can define the angle? So if we observe, this inclined line is making 45 degree angle with the vertical, and this vertical is nothing but 2000. So here is 45 degrees. So we can define 2000 cos of 45. Now no need to resolve this R2 because it is perpendicular to the inclined plane, and we have to consider only forces parallel to inclined plane. Now we will put the data. So forces parallel to inclined plane. So here is this main line. So this force C cos 45 plus 15. So 45 plus 15, that is 60. So C cos 60. C cos of 60. Now this is in upward direction, so we will consider here this plus sign. Then here P cos of 15, so it is in downward direction, so minus P cos of 15. Then next one is 2000, so 2000 it is also in downward direction, minus 2000 cos 45, minus 2000 cos of 45, which is equal to 0. So C value is known, so only one unknown term, that is P, and we will find out. Value of C is 4899. So when we solve this, C cos 60, then 2449.5 minus P cos 15, that is minus 0.96 P, minus 2000 cos 45, that is 1414.2 is equal to 0. Now we will transfer this 0.96p to the right hand side. So it will become plus. And when we solve this, p is equal to 1078.43 Newton.